Good afternoon, everyone. I'm Cindy. Today, I'm presenting my project, the Chicago Building Energy Anomaly Detection System. Here's what I'll cover today. I'll start with a demo of the system, then walk through our methodology, the dataset, detection results, and validation. Finally, I'll share key findings. Next, let's start with a demo of the system. This is an interactive Gradio app where you can filter buildings by energy use, property type, and year. It shows anomalous buildings on a map and lets you explore their energy profiles. The tool helps city planners visually identify high-energy buildings and adjust detection thresholds. Good afternoon, everyone. Today, I'm excited to present Chicago Building Energy Anomaly Detection System. This platform analyzes energy consumption data from over 17,000 buildings across Chicago to identify energy use outliers and inefficiencies. Let me walk you through how it works with several real-world examples. In our first demonstration, let's examine office buildings. The average energy use intensity, or EUI, for offices across all years is 86. If I set the threshold to 100, we find 62 buildings flagged as anomalies. This represents 7.1% of the total dataset. Now, let's look at hospitals. The average EUI for hospitals is 232. When I raise the threshold to 300, we identify 15 anomalies, which is 1.7% of the dataset. These are facilities using significantly more energy than typical hospitals, which could point to operational inefficiencies or particularly high-intensity medical services. Moving to laboratories, the average EUI here is already high at 371. If I set the threshold to 500, which is well above the average, we find 33 anomalous buildings. That's 3.8% of the dataset. This shows that even within an energy-intensive sector, we can still pinpoint the most extreme energy consumers. What about buildings that are typically very efficient? Consider senior living communities. Their average EUI is below 10. If I set the threshold at 20, no buildings are flagged. However, if I adjust it down to 17, we find 2 anomalies. Finally, let's examine how the system reveals trends over time. If we filter for laboratories with a threshold of 100, we see a clear pattern. In 2014, only 3 buildings were flagged, representing 0.3% of the dataset. By 2019, that number had risen to 21 buildings. This ability to track changes year by year provides valuable insight into evolving energy consumption patterns. The system also provides interactive visualizations. For example, if I set the EUI to 4 for senior living communities, 2 types of graphs appear. The first is an energy consumption density map showing only the 2 qualifying buildings. You can move around the map, zoom in, and navigate to explore geographical details. The second graph displays the distribution of EUI values, and the user can also hover over any bar, reveals specific details about individual buildings. Lastly, all results can be exported directly as a CSV file for further analysis. The exported data includes comprehensive information such as property type and name, address, EUI and GHG intensity values, floor area, total greenhouse gas emissions, anomaly scores, and the data year. This makes it easy for facility managers, analysts, and city planners to conduct deeper investigations or plan targeted interventions. This wraps up my demo. Thank you for your attention. My data comes from the Chicago Energy Benchmarking Ordinance, available on the Chicago Data Portal. I started with over 28,000 records from 2014 to 2023. After cleaning, removing incomplete submissions and invalid entries, I worked with 17,000 buildings. Key features include property type, floor area, energy, use intensity, and greenhouse gas emissions. Methodology, I compared two detection methods, a simple 2 standard deviation rule and isolation forest, a machine learning algorithm. The 2SD method only found 214 anomalies, or 1.2% of buildings. In contrast, isolation forest detected 869 anomalies, or 5% of the dataset. Therefore, I chose isolation forest because it handles skewed data, captures feature interactions, and scales well to large urban datasets. Isolation forest uses a contamination parameter to estimate how many anomalies exist in the data. I tested several values and chose 5% for 3 reasons. First, it aligns with U.S. Department of Energy estimates that 5–10% of commercial buildings have high energy saving potential. Second, 870 buildings is a manageable number for city audit teams to investigate. Third, it shows strong agreement with Chicago's official energy rating system, which I'll explain next. To validate the model, I cross-referenced my detected anomalies with Chicago's energy rating system, where 1 star means lowest efficiency. 78% of 1-star buildings were also flagged as anomalies by my model. This shows that my system works statistically and it identifies buildings already recognized as inefficient by the city. Next, here are some of the most anomalous buildings. For example, Keating Hall, a university building with extremely high EUI and GHG intensity, Piper's Alley, a performing arts center, Cambria Hotel. All of these show energy and emission values far above their peers. However, not all building types are equal. Hospitals had the highest anomaly rate at 73.5%, followed by laboratories at 68%. This is due to their 24/7 operations and specialized equipment. In contrast, multifamily housing had only 0.3%, showing very consistent energy use across residential buildings. I also tracked how anomaly rates changed from 2014 to 2023, which found a 16-fold drop from 31.3% in 2014 to just 1.9% in 2023. This suggests real citywide energy improvements, likely driven by benchmarking policies and more consistent reporting over time. Some buildings were flagged year after year. I found 80 buildings that were anomalous in 5 or more years. These include major hospitals, large office towers, and specialized facilities like labs and convention centers. These repeat offenders are clear targets for policy intervention. To reiterate my validation approach, a 78% match rate confirms the model's practical relevance and accuracy. In summary, first, citywide energy efficiency has significantly improved over the past decade. Second, hospitals and labs remain high priority sectors for energy intervention. Third, repeat offenders need targeted support to overcome barriers to retrofit. Lastly, isolation forest proved effective in detecting complex, multivariate anomalies that simpler methods missed. This is the end of my presentation. Thank you for your listening.